Sewage or wastewater or used water as it is called, coming out from homes and apartments is a challenge for the city. It has to be collected, conveyed, and treated and put to use. The city has been using wastewater informally. Farmers have been picking it up and using it for irrigation. Actually, not a drop of wastewater goes waste. It's been used for agriculture. But systematically, the city has been setting up sewage treatment plants. It's been setting up regulations to push for decentralized sewage treatment plants. And in one particular case, the decentralized treated sewage is actually being blended with fresh water and being drunk by a group of residents in an apartment. In another case, treated wastewater passes through a wetland, fills up a lake, recharges groundwater, and enhances biodiversity. There are many roles for used water. One of the largest projects of transfer of treated used water is undergoing in Bangalore. Here, treated used water is being pumped to the neighboring drought-affected districts of Kolar, Chikballapur, Bengaluru rural, where farmers are struggling to manage water, where groundwater tables have sunk very far below, and used water is now filling up lakes in these areas to recharge the aquifer and to provide water for irrigation as a drought-proof and climate-proof measure. Come, let's hear about this.
Sewage becomes a real source of the new water, where we need to really treat it to the required purpose, whatever it could be, and then reuse it. One of the things that already about more than about 50 to 60% of sewage water is being treated. Even I will say, even put it at much more than that, and used for different purposes. One of them, of course, is letting out in valleys is always there, and filling up of the tank. One very important project which BWSSB is supporting the government of Karnataka is in transferring recycled water, secondary treated water to Kolar and Chikballapur to fill up more than 138 tanks in Kolar itself. And there's a similar project in Chikballapur and also one more in Anekal. So all these parched areas, getting this water from the city will make a lot of difference because of the moisture buildup, groundwater recharge. All these things are going to happen. And as these things are going to happen, we are going to see a substantial change in the environment and ecology in these areas. Already, some of the 50% of the tanks in Kolar area have already been filled up out of 138, about 70 tanks. People are already seeing complete change in the way the environment and the ecology is behaving. So down the line, when the full potential of this scheme is met, so there's going to be a commendable change in the way we look at the water in these areas. And also I should mention that there is another project which the BWSSB and BDA are actually taking up, where tertiary treated water will be actually supplied to one of the new layouts in Bangalore called Nadaprabhu Kempegowda layout. So that way the people are looking at use of the recycled water to the extent possible. One very important to take away from the recycled water transfer is many cities are always seen as guzzlers of water as well as energy. And here is a project where with the recycled water transferred to Kolar, Bangalore no longer becomes only a sink. It also becomes a source for the neighborhood, neighboring areas of Bangalore city.
Bangalore, like the metering, has also a long history. Bangalore is a very undulating terrain, and the valleys have been, there are properly defined valleys. There are 4 major valleys. The valley system was first recorded by the British engineer by name De Croce. He is the first person who said the sewage cannot be collected at one point in Bangalore. It has to be collected at several places across the valleys, along the valleys. He located about 8 valleys where the small sewage treatment plants can be built. One such first identified was the Suntal Farm that is close to Koramangala. That was the first sewage forming in some sort of a sewage treatment. Since then, the treatment plants have been BWSB is keep adding in the year 1973, the primary treatment system was adopted for the two valleys, Koramangala and Chalgata, and also for the Rishpavati Valley. In 80s, the Hebbal Valley was also included. In the 80s, the type of treatment which was given to the sewage was of secondary quality. In the primary, it was only the suspended solids and partly the BOD that was removed. And in the secondary, the entire BOD was removed. Of late, now the treatment plants are designed with the nutrient removal. The sewage which has got, normally you will have the nutrients, the phosphorus and the nitrogen, they're also completely removed. The quality of sewage treatment that is happening in Bangalore is extremely good. And this water is being, led into the valleys and also the lakes. Currently, there are 26 operating sewage treatment plants in Bangalore, close to about 1,200 MLD capacity. That much wastewater is being treated, and 3 more are being added. Maybe probably in a few months, those 3 plants are also being commissioned. And in next 3-4 years, another 40 plants are being added. Of course, the capacity is close to 140 MLD. All the sewage that is generated will be treated, and that treated water now is being given to the farming for the Bangalore district area, and as well as for the Kola. This water has got a high nutrient value because of inconsistent rainfall for so many reasons like climate change. The intensity and the frequency of rains have drastically changed. This water, which we call it as a reclaimed water, is helping the farmers in a big way. And now you can see there's a lot of greenery happening, towards the northern Pinakini side and as well as southern Pinakini side. And the job that is being done is quite immense.
I'm Dr. Ananth Kodavasal, Director of Ecotech Engineering Consultancy, based out of Bangalore in India. We have been in the business of wastewater treatment, both domestic as well as industrial wastewater, for the last 34 years. Treatment, recycle, reuse, that is our mantra. We are operating and maintaining nearly 90 plants in Bangalore, Chennai and Pune. And in all these plants, we recover and reuse nearly 50 to 60% of the community's requirement if it is a residential complex. It goes as high as 85 to 90% in the case of commercial complexes such as malls, hotels, where there's a huge HVAC, cooling water requirement. So this is the benefit of a good STP. 3 cardinal rules for a good STP. Good design, proper engineering, and then proper operation and maintenance. All 3 things are aspects which need to be at 100%. And being a trained chemical engineer, I'm fond of my saying, there is a zeroth law which sits above all these considerations, and that is selection of the most suitable, most appropriate treatment technology. The old adage goes, one size does not fit all. Similarly, one STP technology does not fit all sizes. Depends on the scale and size of the STP. And let us take the case of Bangalore city and the distributed STPs across the city in residential complexes, commercial complexes, malls, hotels, educational institutions, hospitals. These are all mini and small STPs in the range of, let us say, 100 KLD to maybe 3000 KLD. 3000 KLD is the largest STP we operate and maintain in Bangalore. So nothing goes above 5000 KLD, where the larger size STPs, where the other technologies come into place. But we are strong advocates of the time-tested, classical, conventional extendation activated sludge STP for all these mini and small STPs, and we speak out of experience. We operate and maintain nearly 90 plants in Bangalore, Chennai and Pune, and all of them work. All of them are based on the extendation. And many of them have been converted from SBR to extendation, from MBBR to extendation, from MBR, membrane bioreactor, most high-tech, most modern technology, to extendation. So we have to understand which technology is best suited for this particular application in the mini and small scale STPs, especially in the residential commercial space. Let me tell you why SBR is unsuitable in these STPs. SBR technology treats the daily discharge of sewage in 3 equal batches. But we all know, in a residential or a commercial complex, the sewage is not generated in 3 equal installments. And therefore, by default, by nature, SBR is totally unsuitable in this particular application. Let me take you through why MBBR technology is unsuitable. MBBR is unsuitable because as developed in Norway in the 1990s, MBBR technology mandates a primary sedimentation stage. In domestic sewage, primary solid is basically human feces. Human feces, when separated, is difficult to handle in a small mini STP in a residential complex or a commercial complex. And therefore, MBBR is suitable in large municipal treatment plants. It is totally inappropriate in a small STP. So these are the technologies which are prevalent in Bangalore, Chennai, Pune, Hyderabad, and that is one of the reasons more than 80% of the STPs are dysfunctional. So what is the solution? If you have to change the technology, convert it to externalization, do redesign, re-engineer, operate and maintain. Just to take you through the numbers, there are more than 3,200 STPs in Bangalore alone. More than 80% are dysfunctional, as I said. More than 450 MLD of sewage is under treatment in these STPs. If you can just make them work, you can recover and reuse more than 300 to 350 MLD of water for secondary uses from your own doorstep, at your own doorstep. No other source of water, neither Kaveri, no river water, no groundwater, no borewell, no tanker water, no municipal supply is going to guarantee uninterrupted supply in the coming years. STP is the only guaranteed perennial source of water. So please respect your STP, try to make it work. Even if it costs 30, 40, 50 lakh of rupees to set it right, please do so. The payback period is just a matter of months. I know we have done more than 60 of these surgeries in the past 10 years and all of them work. And all of them, the payback period has just been a matter of months. So multiple benefits from an STP. 1, ensuring your water security in the future. Number 2, economic benefits. Number 3, protection of the environment. And 4, conserve and preserve freshwater resources, natural freshwater resources. Multiple benefits from a good STP. So please respect your STP, make it work for you and for the environment. Thank you.